I guess I bring the things that I need, but I feel like no. Okay, cool. Solid. Solid. Leave this up for later. And I always wanted to do this. What's up, everyone? No, come on. Come on. No. You gotta press. No. With the red one? Yeah, that's fine. Should just come on. Yo. No. Yeah. Oh. Okay, now it's. Yo. There you go. Oh, yeah, let's go. All right. What's up, everyone? Thanks for coming out to our meeting today. Very basic introduction to computer vision. This is a field that we haven't really covered very much, really throughout this year. If you guys were with us in the fall, it was just basic machine learning principles, and all of last quarter we really went through recording, right? Yep. Right. And we pretty much just went through a lot of the neural networks that a lot of common neural networks, RNNs, LSTMs, CNNs, we went over perceptrons, all of that last quarter. So this quarter, and especially this meeting in general, this is going to be a little bit of a different meeting, to say the least. This quarter, we want to try out different things, and we want to see what sticks. And at the end of this meeting, there is going to be a feedback form. Please fill it out. Your feedback means a lot to us, and how we can continue to improve things going forward for future meetings for next year with you guys. We want to make this experience nice. We want to make, and it's dead. I think it's just dead. Oh, whatever, it's fine. Oh wait, but then there's no mic. Webcam mic. Yeah, the webcam mic. How good just keep going on. Yeah. All right. Yeah, this is low battery. Okay. I don't know how to charge it though. All right. Yeah, so if you guys could fill out the feedback form at the end, it would be great. We want to continue to make this the best experience for you guys going forward throughout the rest of this quarter and for next year as well. This time it's going to be a little bit different. This is our last coding workshop of the quarter. So the way that we're going to do the code is going to be a lot more different than normal. Usually we provide you guys a Google Colab notebook. And then from there, what we do is we have you guys fill in the blanks. Last week, I know we didn't really have anything, but it was still very relevant. The code was very relevant, and the topics that were covered are still very relevant to the code. This time, it's going to be our last one. And we want to get your feedback, not just on this workshop, but all of our coding workshops that we've done this quarter, last quarter, and in the fall, for what you guys think that should be improved, what you guys think, what you guys want to see, what you guys think we did well, and all that going forward. So to kickstart it, first things first, this is, like I said, this is going to be very different. For the project at the end of the slides, we're not going to be using Google Collaboratory. This is going to be a very basic, the project that we're going to be doing is a very basic hand tracking project. What you guys are going to be able to do is the code that we write today is a very basic project in computer vision using the OpenCV library and MediaPipe, which they already have some of the hand tracking modules instantiated. So what I want you guys to do, if you guys don't have any of these installed, any of these Python IDEs installed, now is the time. So in the end, you guys can catch up. I'm pretty sure most of you guys have it, but the number one thing is do not use Colab. Do not use Colab, it's not going to work. Use Visual Studio, use PyCharm. If you're feeling really based, feel idle, it is up to you guys, right? But if you choose any Python development environment of your choice, just don't use Colab. It's not gonna work, right? So without further ado, let's hop into this very basic intro into computer vision. This week's meeting and next week's meeting are gonna go pretty hand in hand. This week being an intro into computer vision, and next week being a full discussion on autonomous vehicles and how they work, and how what we cover today is applied next week when it comes to how they work, the safety, the ethics, and the AI and machine learning behind it. So I'm gonna open the floor to you guys. Before this meeting is gonna be very interactive. I want you guys to speak up, not just stare at me or at your computer. But what is computer vision? What do you guys know about it? What have you guys heard about it? Talk to me. What's up?
A computer sees it sees an image and then it recognizes an object in the image, like a stop sign.
Okay, sure. That's exactly. That's one of the ways that is one application of computer vision. Anyone else? Nice. Fantastic. Okay. Yeah, so computer vision is pretty much exactly what you said. What we want to do is, given some image, some videos, some live feed, what we want to do is we want to recognize objects. We want to be able to understand what is happening in that image. For us, we know what's going on. Our computer doesn't know what's going on. Computer vision is, like I said earlier, this is one of the fields that we have not really covered in that much. You guys remember really like our second meeting of the quarter where we talked about the different fields in artificial intelligence. Sorry, not the second meeting of the quarter, second meeting in the fall, where we talked about the different fields in AI. We talked about how computer vision is still up and coming, it's still rising, and it's not the biggest field in AI, but it's still something that it's great to know about, and it's an up and coming field where a lot of research and development is happening as well. So what are some applications of computer vision, regardless of just like in the stop sign, or where have you guys seen it? What are some of the obvious ones? I know you guys know some. You guys gotta speak on it. Some. What's up? What's your guys?
I saw GPT-4 had like photo processing.
Yeah, that's actually something really interesting. I need to really read into GPT-4, but that's exactly one of the applications. Anyone else?
Autonomous vehicles.
Yeah, exactly. Autonomous vehicles, when it comes to detecting objects on the road, classifying objects between people, stop signs, anything. Anything else? Nice. All right. Cool. So all of what you guys have said are extremely valid. It's a field that for me, when I think of computer vision and CV, the thing that I think about the most is autonomous vehicles. It's the thing that comes to mind the most, where perception technology, and the biggest thing is that it's a harmony between the images and the video feeds, or live video or live images, and the neural networks and the models that you use to create. You can't have one without the other, especially in this field. And the biggest thing that you guys are going to see, especially when it comes to actually developing these models and when we actually write code for it, is you can't write a neural network for a general case. You have to be wary of the image types that you're getting, and to be wary of the technology that you're using to get those images or those videos. You can't just write something in general. It's not going to work, especially as we go into different use cases and we go into some of the different techniques that are used in computer vision. So we're not going to go too in depth into the math today. I don't want to scare you guys away with the math and the amount of linear algebra that there is in this field when it comes to matrices. When we're going to talk about transforms, and there's a lot of math involved. I don't want to go into that too much today, but what I do want you guys to know is that when it comes to developing and you guys working in, if you guys do work in computer vision or do projects in computer vision, Wink on the Sky's No Limit project, you guys want to stand out and you want to do something in computer vision, make sure you guys are aware that if you guys are using a certain camera, or if you guys are using certain images from a certain database, you should know what the image types are, you should know where they got them from. And once you guys understand that, you guys will be able to write models for it so that you guys won't have any issues with actually training your model and actually testing, right? So let's move forward, 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 hello. Nice. All right, so the first thing that we covered is, at least in the harmony, is between images, videos, and live feeds, right? As it comes to images, if you just, I think this thing is just straight up dead. Nice. I'll just point. So as it comes to images on this side, as if you just take a square image and you process it through, can some of you guys give me an example of a neural network that we have talked about, where you give an image to it and you get some classification out of it? Exactly. A convolutional neural network. So what we can do is we can simply pass an image. Is it up? That's up. Did I turn it off?
God.
Nice. So what we can do is we can just straight up pass an image through a convolutional neural network, and we can get different classifications. Okay, this is a person. This is a cab. This is a stop sign. Whatever. Right now, if you get to an image, so images are fairly straightforward. Now the question is, how do you deal with videos and how do you deal with live image processing? Right, that's something that we're going to actually be doing today. So when dealing with live image processing and dealing with something a little bit more like this, where you'll be able to track your hands and track your motion with that. But when it comes to videos, how do you process a video? How do you continuously process a video? So here's a question. It's a fairly straightforward, not fairly straightforward, but I want to see if you guys know. A video is nothing but a continuation of images, right? So now the question is, how do you continuously feed images into a neural network at a rate that it understands that it's moving and understands that this process, right, is not just still, and it has to continuously adapt to what you're giving. And that cuts into the question of a live feed. So this is when it comes to autonomous vehicles. If the car is continuously getting video data, how do you continuously feed it in? And what algorithms are being used to detect and to predict to keep you safe in a car, right? These are the big three, I would say, that are perception when it comes to computer vision. So for us, when we look out into a crowd, we're able to identify, right? Our main way to perceive is through our eyes, right? Our computers, and for computers, that's where it comes into perception technology. We can either give it the image through something that's already pre-trained, we can give it a video, or we can live track it through different cameras, right? And obviously, I've said it before, you are going to use your own cameras. Make sure you know which ones you're using so that you can be able to write models around. What's up?
How do we ensure we maintain a certain amount of latency while doing this?
That is-
Because those computations are complex, aren't they?
Right, that's just more pertaining to the model that you guys run. I don't want to, at least for today, as it depends on the scenario that you're in, if you know what I'm saying. Where can you repeat that one more time?
Oh, well, I can jump in.
What's up?
I think that's like an issue right now that like is being dealt with at the school. I went to a conversation with some guy who's working on edge devices specifically and creating like processes that will work with the SoC units on the devices, since the processing is all built in together. So I think like in general, like on those edge devices, the computation problem is like a big kind of bottleneck right now, and that's what people are working on. If you want to work on that, there's a ton of people upstairs who are dealing with those sorts of issues.
Sweet. Okay, so let's get into the second part of this kind of let me see what I'm on time. Okay. Of this kind of harmony between our images and our videos and the perception and the neural networks. Most common ones, obviously, convolutional neural networks. We've seen a rise in actually support vector machines and more importantly, support vector classification. When it comes to computer vision. Lastly, the advent of transformers and one of the most popular neural networks in computer vision, ResNets, right? So before I hop into ResNets, what I want to talk about a little bit is why not just use straight up convolutional neural networks, or why not just use transformers, or why not just use support vector machines? The biggest or the most commonly used neural network in computer vision right now are ResNet, and obviously there are more there's more work being done with transformers, right? So the question is, we did convolutional neural networks already. Based on what you guys know about convolutional neural networks, what could be the biggest problem with using a convolutional neural network to say, or a basic convolutional neural network to process a live video feed?
Convolutions are pretty demanding functions because you're applying a kernel across a subset of pixels, and
Right.
you need to know what pixels to apply that. You apply that on, but those calculations take time. Is that the problem?
That is one of the issues. There's another one that is pretty prevalent. So time to complexity is huge, but that has to deal more with the architecture of the model. Now, the question is, what about the architecture of the CNN is causing it the delay and is causing it is not giving us the most accurate results?
It compresses the image.
Not compressing the image. Anyone else want to give it a crack? I'll answer after. Anyone else want to give it a crack? Any of you guys?
Specifically with what? Like, why not just use convolutional?
Why
model?
not just use a convolutional neural network?
Aside from the fact that it's expensive, it's lossy.
Exactly. That's one of the biggest issues as well. Well, and especially when it comes to convolutional neural networks, the biggest issue is actually in the back propagation, where if you continuously provide a live feed, if you're continuously providing images, especially to, how many of you guys have heard of the VGG16 or VGG19 architecture? Yes? No? Maybe so? So, well, VGG16 or VGG19, these are two of the different VGG type nets, where it's just a convolutional neural network with about 16, or with VGG16, 16 layers versus VGG19, which is a convolutional neural network with 19 layers. And the biggest issue with this, and especially when it comes to neural networks, or to computer vision, is in the back propagation, where we have something called the vanishing gradient problem. So we talked about this before. Does anyone remember what it is? What's up?
When you're continuously doing like multiple back propagations and stuff, like if you have like very small gradients, if you keep on multiplying those gradients and you get an even smaller gradient.
Right. Exactly. So that's the biggest issue when it comes to computer vision and just using convolutional neural networks. The vanishing gradient problem is extremely persistent, especially when you use some of the architecture that we used in the past, which is VGG16, VGG19. The biggest issue has always been with the vanishing gradient problem. So now the question is, how do we fix it? Well, we could use a support vector machine. We can use support vector regression or support vector classification. Let's say we wanted to identify like a stop sign. We can use support vector classification, and we can identify it pretty simply. But there are a lot of issues with it. Support vector machines in general, especially when it comes to computer vision, especially with some of the research being done with it, there's a research group, I believe, out of, I forgot which paper it was I read, I forgot where they're from, but where they were experimenting with support vector machines when it came to testing it with a certain type of camera, a certain type of autonomous vehicles, where like, what if we could use support vector classification and instead of a VGG network, What they found was it's not the most accurate. You end up actually ignoring a lot of, it doesn't classify everything, and then doesn't do it in the time that we needed to. Time is a big thing. And support vector machines, although it can be done if you guys want to do it for your own projects, I'm encouraging you guys to experiment and to actually see the difference between these four. So if you want to try it out, please do, and you can experiment with the latency and the time that each one takes. You'll find that convolutional neural networks, a Bayes convolutional neural network will actually take the longest out of all these. And then you'll have support vector machines at a very close second to last. And now comes the third thing. This is fairly recent, the advent of transformers. Transformers, I will be very honest with you guys, is something that I am not the most, I cannot talk about that in detail like I can some of these other topics, where transformers are still fairly new and it uses something called multi-headed attention. And that is a continuation or an innovation on self-attention, where especially in image processing, transformers, this is very new, where I believe Google has created a new type of image generation using transformers.
Oh, really?
Yeah, I'll send you the link for that.
Nice.
So like, Google has created something like that using transformers versus some of these actual other neural networks and processes that we're used to using. And lastly, the most common and the solution to our convolutional neural network problem, ResNets or deep residual networks, where, oh, so I forgot I had this slide, but is it that easy, first of all, if we have our neural networks and we have our images, if we just, just stick them together, it's just gonna work. No, it is not. Why? It's a lot of math. And math sucks. All right, math sucks. Look at all this. Yuck. Disgusting. This is just like what I found. Just like if you just look up computer vision and you just straight up look up some of the formulas that are being used, you are going to run away. This is why this is a graduate class here. You cannot take it as an undergraduate student. If you guys end up doing grad school here, please do come take the computer vision course. Maybe the math won't be as scary for you then, but trust me, it will never get not scary as looking at all of this. So my question to you guys actually is, why do you think, this has nothing to do with the AI itself, but why do you think there's a lot of math and a lot of linear algebra involved in computer vision? What's up?
You can think of an images and add an array of colors or an array of color values.
Right.
So you have to know how to process those color values and recognize objects within those images, because there are multiple objects like in the image you showed.
Right, exactly. The biggest thing is when you are working in computer vision, the projects that you guys are dealing with are not, you can't really translate them easily across different subjects. Let's say I wanted to identify a person versus whether I want to identify a stop sign versus what if I want to identify a chair or an expo marker or I don't know, a projector. It's different all across the board. There are different, you will have to generate different formulas, different models just for specific classifications. This is not fun to look at. That's why we're not going to be diving in too much into the math. But what I do want to do is go over some of the basics and one of the most important foundations in computer vision, which is deep residual networks or ResNets, and how this solves our vanishing gradient problem that convolutional neural networks give us, specifically with a VGGNet towards a ResNet, right? Obviously, there are different variations of ResNets, but the basic architecture, is the same. What we want to do is, if the residual network is still very similar to a convolutional neural network, but what it comes down to is I never thought I would say this, but it comes down to taking derivatives and partial derivatives, where if we change the function of our neural network. So in this case, f of x is our neural network, where we have a weight layer, we'll have, if you guys, or I'll ask you guys, what are some of the main stages of a convolutional neural network?
Convolution pooling.
Yeah, so you have a convolutional layer, you'll have a pooling layer, and you can have an output layer as well. Pretty sure I'm missing one there. But it's still remains the same. You'll have a ReLU activation, obviously in the middle, and towards the end, you can have, what's up?
It's the flattened layer.
Yeah, flat layer, at the end,
Yeah.
right?
Beginning, but
Yeah,
yeah.
at the beginning.
No,
Or
sorry,
it's at
end
at
of
the
the
end.
convolution.
Yeah.
Sorry, yeah.
At the end of the convolution, you have your flat, right? So what we're gonna do is before we get into a residual block, we're going to have, it's still a convolutional neural network. The very basic architecture of a residual neural network is a CNN. So that's what we're gonna say f of x is. So now let's say if we're just going to take the derivative of a function, you're going to end up with a different gradient each time. You're gonna end up with a different slope each time. And with the vanishing gradient problem, this is exactly what we want to avoid. So how do we fix that? Well, what if we give an input into a residual block? Let's give it something called an identity to it. So if we add on to it, now what happens if we take the derivative to this? If we take the derivative with respect to x of this function, that answer is just 1. So you don't lose anything going between blocks in a residual neural network. Right? What's up?
How does the vanishing gradient problem also apply to ReLUs?
So it depends. I wouldn't say.
So ReLU, yes, technically does have vanishing gradient problems because you don't have any inhibitory values. So anything less than 0 is going to be 0. This is solved by doing something like SILU or LU or leaky ReLU, or you leave in a little bit of negative value. You just need to base, all of them more or less achieve the same purpose of just adding nonlinearity though. So more or less, if you use ReLU, you shouldn't really have vanishing gradient unless your network's really big.
Then what's the point of adding the plus x?
So in this situation, especially when you go towards a convolutional neural network, right? What this does is, especially when we talk in respect to computer vision, let's say with respect to the projects that we have, the work that's being done in CV, when you are dealing with lots and lots and lots of image and video data, when it comes to a convolutional neural network, it won't be able, it's a time variant as well. This you can stack onto each other and you can have thousands, if not hundreds of thousands of layers of residual blocks. Whereas with the convolutional neural network, you will end up with a very slow process and you won't get it in time, and you'll end up, if you think about it with respect to an autonomous vehicle, if you're just going to use it, you're going to end up processing it and you're going to end up crashing. So that's the last thing that we want. Right, so where have you guys seen this before? Look to last week and the diffusion model in units, or in the UNet. The UNet is primarily, or one of the building blocks of the UNet are residual neural networks. It allows the network to scale up, so regardless of how much data you give it, it will be able to handle that data, which is why we're giving it an identity, so we don't lose anything going between blocks. So this is the biggest thing I wanted to touch on. What's my time? Okay, 6:36.
Yeah.
Okay. So this is the biggest thing I wanted to touch on, but last thing I wanted to just very briefly talk about Fourier transforms. Have you guys heard of Fourier transforms before? Yeah.
Big fan.
What is
If you have a wave that's in a time, it's in the time domain, it'll transform that to give you a value in the frequency domain. So
Right.
it's basically a frequency decomposition.
Yeah, exactly. So now my question to you guys is, well, I guess I already put it up here, but how do you guys think this can be used in computer vision? It's used a lot with audio compression, audio decompression, but when it comes to images, how do you guys think it can be used? Based on what you guys know, or for the people who do know, where do you guys think it can be used?
The same way.
Yeah.
FFT is, or fast Fourier transform is used for video and image compression. It's based on what's on the slides here and the magnitude spectrum of the image. If you take two Fourier transforms of an image, what you end up getting is areas of high frequency, which is toward the middle, and low frequency towards the middle and high frequency towards the edges. So you can compress the images by basically just cutting out the edges of the transformed image and then doing the reverse Fourier transform twice and get a compressed version of the image. Yeah.
Why do you do the Fourier transform twice? Once it gives you frequency, second time, okay, technically that's frequency for a sinusoidal wave, but here you don't exactly have a sinusoidal wave.
So I can't answer to you in a sentence exactly why. Just my suggestion would be to take a Fourier transform of an image once and then try and compress it. You are going to have significantly more lossy compression. The information isn't as localized, if that makes sense. Just trust me, to get like an image, pass it through a Fourier transform. There's literally loads of libraries that use this. Just like I think in NumPy, there's actually an FFT. You just do like .fft attached to a matrix, and that'll spit out the Fourier transform of that. Do it twice and display it using like Matplotlib. You'll see something that looks more like the magnitude spectrum. Basically, what that ends up doing, you'll see lots of low frequency stuff in the middle and high frequency stuff at the edge. And so then what you can end up doing is zeroing all the stuff at the edge, reversing it, and then displaying the image again. You should see something that's compressed. But yeah, just try it. I really can't explain exactly how it works because I'm not a math major and I haven't done a lot of this stuff. I just know how it works loosely.
Yeah, so when it comes to Fourier transforms, I just wanted to bring this up towards the end before we get into some of the code where what we want to do with an image is we want to identify some of the high frequency components, some of the low frequency components. So it might help us identify an image, that might help us classify an image. So what we're going to do is we're going to put even an input image and we're going to identify some high frequency components, more detail, versus some of our lower frequency components as well. So that's the max I wanted to get into this because it's what, 640?
Yeah, roughly.
And I want to get into this project. I think it's super cool. It's super fun. And it allows you guys to branch off into maybe adding on to it. So here's what I want you guys to do as talked about at the beginning. Open up one of these if you guys have it. Visual Studio Code, PyCharm. You want idle? Was it good? Oh, yeah, sweet. If you're using idle, remember. But my biggest thing: don't use Colab. Have the IDE of your choice open. We're going to be doing a hand tracker today, and just playing around with it. And then from there, if you guys want to play around with it more, let me know. I have resources for you guys on projects that I've done in computer vision and projects that are just circulating online that help me and that are just super fun to do in general. So if you guys are still interested afterwards, just shoot me a message and I'll help you guys out when it comes to this. So like I said, this is going to be a little bit different. I'm going to be walking through code with you guys. We're going to be doing this step by step, and then hopefully by the end, you guys have something cool and something you guys want to branch up onto as you guys continue to play around. Yeah. So yeah, I got you. Oh, and then also, I want to keep. All right, I'll put that up in the end. Yeah, the question is time. It's 41. Yeah. Okay, cool. Cool. So I'm gonna do this on a basic Google Docs. You guys can put this into your IDE of choice.
Bonus points for Vim.
Yeah, bonus points for Vim. If you guys do it in Vim, that's hats off to you guys. But that is some major respect. So the first thing that I said at the beginning is what we're going to be using is the OpenCV library. It's one of the most common computer vision libraries. So what I want you guys to do, if you guys are using PyCharm, then in preferences, you guys want to import, you want to use, you want to find where it says OpenCV-Python and you want to import that. If not, what you want to do is you want to pip install OpenCV. Let me see the actual command. Hold on for you guys. Let me go to my terminal. You want to pip install OpenCV-Python equals 4.5.3.56. either one works. I prefer this one is the most safe. You guys, I can guarantee that it'll work for you with this one. I'm not so sure about this. This one might be a little bit outdated. This one I know is up to date. So I would pip install this or find this version before hopping into it. And then once you guys have done that, you want to import CV2 from that library. And then, what's up?
Use of it.
Oh yeah, for sure. My bad. Is this too much? Might be too much. Okay, cool. I think, is this good? Okay, so you want to import CV2, and then what you want to do is you want to import something called MediaPipe as MP. So the question is, what is MediaPipe? What are we even going to be using it for? MediaPipe is going to give us they do a lot of the computation for us, where when we talk about like ResNets and when we talk about classifying, especially when it comes to our hands in this particular case, we want to use MediaPipe already has that library and they do all that computation for us. So you want to import MediaPipe as MP. And then the last thing we want to do, especially as we want to track time, so we want to import time. So once this part of it is done, then we can hop into some of the code and getting this still on the road. So once you guys have all this installed and of all this up and running, let me know and then we can get into it. Give me like a show of hands. Got it?
Do we have to pip install MediaPipe as well? Is that separate or is that with OpenCV?
Actually, that's a good point. I didn't mention that. I would pip install MediaPipe as well. If it's not automatic for you guys, pip install MediaPipe. Like
And if you get a version complaint, just
yeah,
hit upgrade.
yeah.
Same for OpenCV.
Yep. And then once you guys are done, just wave your hands or do whatever. Let me know that you guys are done because I don't want to leave too many people behind. And we have 15 minutes. Yeah, I think we can get this done in 15 minutes. You got it?
Got it.
Awesome. Everyone else? You got it? You got it? Not quite. What's up?
It's taking a while to install it.
Okay. All right.
Honestly, might just help to write the code while it installs.
Yeah.
It'll just complain
Yeah.
syntactically, but it doesn't.
That's good. So, yeah. So as long as it's installing and as it all installing for everyone else, you guys all have it in. Dope. All right, bet. So here's the first thing that we want to do is we actually want to capture video using our webcam. You want to capture it using, if you have a Mac, it's cool. You use your phone as your camera if you want to. But we want to use our computer's automatic webcam if you guys have it. Or if you guys have a specific webcam that you want to specify that. But we need to capture our video. So let's say we have some, I'll call it video capture. And I'll set it equal to using CV2. We're just going to call the video capture library or the video capture function of 1. So this will specify our webcam. Cool. And then the next thing from here is we need to import or not import. We need to get our hands and we need to understand like we're tracking our hands, right? And how do we do that? We're going to use MediaPipe for that. So let's just call it like hands and let's set it equal to mp.straightup mp.solution.hands. Solutions.hands. Yeah. So by doing this, we get our hand tracking, and now from here, let's actually, or our module for tracking. And now from here, let's actually get into some of the classes. All right, so let's say, now let's actually, now that we know the specific library, let's call this like tracking, and let's set it equal to, what is it, MP hands, right? Yeah, hands dot straight up hands yum. All right, so now what we're gonna be doing is when we put our hand to the camera, it will identify that, or not yet, what we want to do is we want to be able to identify our fingers, and we want to be able to identify the joints in our hands as well. And we want to be able to draw like dots on it, and we want to be able to draw lines where the bones are. So this MP hands class, and this MP and media pipe as a library, that's what it's going to do for us. So now it's up to us to actually draw on it. So let's say MP draw is going to equal to MP dot solutions dot drawing underscore utils. So what this is going to do is this is going to give us our the basics for actually drawing on our hands, and give it, and it'll give us the basics. All right. Let's see. Okay. Where am I at on time? 6:49. All right, we got 10-ish minutes. Okay. All right. So here's what we want to be able to do. There are a couple things that we want to be able to do going forward. This has nothing to do, I mean, it has everything to do with it, but we want to be able to see what our frame rate is, and we want to be able to actually see if where our camera is operating properly. So that's why we imported time. So I'm going to put something called my capture time, and I'm going to set this equal to 0, and I'll create something called my processing time. So how long does it take? I should stick with the theme. Capture time. I'm going to set this to equal 0 as well. All right. And also, if you guys are feeling behind, I'll post this file to the Discord as well. You guys can check it out afterwards if you guys aren't with it for the meantime. All right. So now let's actually get into. All we need to do now is if let's say it was done and I ran it and I put my hand in front of the camera, your code is going to say that's a hand. That's all that's going to happen. Now let's actually draw on it, right? Let's identify the positions that we need to, and we'll be able to draw on it, right? So let's check it out. All right, the first thing that we need to do is this is going to be happening always, right? We want this in an infinite loop until we want to stop it. Unless you guys just want to run this one time, all power to you. But for this case, I'm going to create a while true loop. I just want to keep this running until I don't want it to run anymore. All right. Now, the thing is, like, what if your camera doesn't work? Well, if your camera doesn't work or you have some error, we want to be able to catch it. We want to be able to catch it first. And the question is, how do we do that?
Right.
You can use a try if you want. I'm just going to use a basic if statement. So I'm going to create a variable called a success, and I'm going to create, remember what a video is, we're taking rapid images in succession. So I'm going to create an image variable. And what I'm going to do is I'm going to use from their library cap.read. All right, so what this is doing is this for both, all it's doing is it's reading in an image, and it's now we actually need to process it, right? But
Where did we define cap?
cap is a function that is imported in CV2.
Okay, so when we want to do cd2.cap.read,
If you already have it, you don't need to worry about it. I wouldn't. Yeah, you're good. All right. So what we want to do is if this cap.read is not, if success is like 0, then we can't continue, right? So let's just straight up do let's just, if not success, what we can do is we can straight up break it, or if you want to, wash it. Okay. You can straight up break it, or you can continue it, and you can just continue in a loop so your code doesn't crash immediately for the end. So I'm going to continue it. You can choose to break it if you want to. I have 8 minutes, goddamn. All right. All right, so then we can continue. So now from here, what we want to do is our cameras are reading things in and at a different spectrum than we are. It's taking a BGR. What we need to do is we need to convert it to an RGB, right? Into what we see, right? So let's actually do that. Let's create a new variable. I'm going to call it our IMG RGB, and I'm going to use the CV2 library that's CVT color of our image that we just captured, and we're going to call CV2 color underscore BGR who RGB. Cool. Now what we want to do is we want to process this. So I'm going to say my results is equal to IMG RGB is to our hands. So hands dot process of our IMG RGB. Okay, how much time? I have 6 minutes. Is it possible to speed run? I think so. Okay, there's not much left. I don't want to deprive you guys of actually understanding it, but hopefully when I code it, it's all self-intuitive and you guys understand. If not, please don't hesitate to ask afterwards or shoot me a message. I will be very happy to respond to you guys. All right. So here's what we want to do. We have what is our goal? We need to identify the joints in our hands. We want to identify the bones in our hands, right? So here's what we're going to do. We're going to say if results, and using our using MediaPipe, there's something called multi-hand landmarks. All right. And now here's what we want to do. Now that if those are there, like if there's a hand in the image, now let's actually identify it drawn. All right. So here's what we're going to do. So let's say for like some hand landmarks in my results, the multi-hand landmarks. How much time do I have? 5 minutes. All right, it should be enough. All right, so now let's go through each one, right? And the way we're going to do this is we're going to go through each point. So we need another for loop, and we need to go through each joint and each bone. So how do we do that? We're going to say, nice. We're going to say for, let's give it an ID and a landmark. We're going to enumerate through this in our hand landmarks. There's a lot of landmarks. Hand landmarks dot landmark. So now we need X and height, width, and we need all the coordinates for this, right? We need the X, Y, Z of all this so we can draw on our hands, right? Let's get those coordinates. And here's how we're going to do it. All it is we're going to take, I'm going to create different variables, say height, width, and color, and we're going to set this equal to img.shape. All right, and let's get the coordinates. So let's just say cx and cy. I'm going to set this equal to an integer, not a float, of our landmark dot x and our landmark dot x plus the width. And we need to do the same thing for y, where we say int landmark dot y plus the height. And then if you guys want to see it as a feed, we can print the ID, so where we're at, and CX and CY. Now, let's actually draw. Sorry if I'm going through this so fast. Let's actually draw on our hands and get actually what we're here for. So here's what we're going to do. I'm going to choose circles. You guys can choose whatever shape you want. I'm going to say cv2.circle. Now we have the coordinates. So on our image, right, what we're capturing, and we want it on these coordinates, cx and cy. All right. And now what we want to do is we can pick the size. So I'm going to say like a size 15, and you can pick the color. I'm picking purple. That's just what I have. And you guys can pick whatever one you want, and we're going to fill it. So I'm going to say call cv2.fill. Cool. So now that we have these, we can get out of our nested for loop here, and we can actually draw it using our mp.draw. So we can say mp.draw our landmarks on img hand landmarks. How much time do I have? 2 minutes.
Run.
Speed run. All right. And lastly, to our hands dot hand connections. So this is giving us the connections between the joints that we want.
Is it indented with just inside the first for loop?
Yeah, this is inside the first for loop. Yeah.
Is that it?
Almost done. We are almost done. We have like 6 lines. Bet. Speed run is real and it is going. All right, come on. No mouse, come on. Okay, cool. So now what we want to do, let's get out of our for loops and let's actually get this done. So we set that capture time in the beginning. So let's set our capture time and let's just set it equal to time.time. All right, that's it. All right, that's just the time as we're getting image feed, right? And we want to get our FPS, and we're just going to set this 1 over our capture time minus our processing time.
Didn't you write capture time in snake case?
I did. Thank you for reminding me.
Same with processing.
Yeah, same with processing time. Ah. Oh. Ah. Oh my God. Oh my. Delete. Okay, cool. All right. So now, so that this continues to go, we're just going to set our processing time to the next capture time. So it's continuously updating. All right, now here's what we're going to do. Let's actually put this down onto our image. So here's how we're going to do it. We're going to put this using the put text command from CV2 of our image this is to put the FPS. All right, actually, how many of you guys want to see the frames per second on your image? Okay, all right, I guess we're doing this. Okay, of our frames per second. So theoretically, if you guys want to finish, you want to do this part, you don't have to, but here's what we're going to do. I'm going to set the size and I'm going to set the location and I'm going to set it equal to, and you can pick a font. I've picked Hershey Plain. You don't need this part, or you don't need this font, but it's up to you. And you can pick the color, which I've picked as purple. 0255. And last but not least, a 3. Okay, cool. What's up?
What's that last 3?
So, all right, so we have our font size, we have our location. 3, honestly, I've forgot at this point. It's been a while. I'm going to assume this is something dealing with our font size. I'll check the documentation, I'll let you know. I'm just trying to finish this up. Last but not least, we just want to show our image. So we're going to do cv2.imshow. I'll just call it image. img, no semicolon. And last but not least, we're just going to do a wait key so that this is all within the while loop, right? So this is just waiting if we want to break it.
This is all indented in snake if result is not multi-hand landmark, correct?
This last part here from capture time equals time. This is all outside. This is still in the while loop. This is not in the if statement.
Okay,
Hold on, let me zoom out for you guys. Just a little bit so you guys understand the indentations here. Yep, hold on. I know it's a little bit small right now, but this is what,
done.
yep. Awesome. So ideally, this runs for you guys and if you guys, if it doesn't and you want to try it out on my own computer, give it a shot.
Saying cap is not defined.
Cap is not defined.
That's it, mean map.
Did I not define, did I skip a? Yeah, yeah, you're right. You're right. My bad, my bad. This is a mistake in my variable naming. This is I call it video capture.
So the int, part of the x plus w thing, provides it should be times w times h.
I believe, yeah, you're right. You're right. My bad. This is bad vision. Oh my God. Yeah, times W and times H. My bad, guys.
Can't open camera by index.
Okay, that is odd. That might have to do with your computer permissions. I know before, at least while running it, you had to update some permissions for this thing to use. So, oh shoot. Pause. Zoom. Why does it do this every time? It's actually annoying. I'm gonna stop this. I wonder if it works. Okay, so now it doesn't see anything at all. Well, open, yeah, so, bro, why do you do this? Bro, you. I'm gonna fill the proper version.
Is anyone facing the same camera problem?
Is it the same camera issue?
I'm just stuff I'm going through the data process.
Where?
Have a webcam on.
Okay,
Maybe it's because I'm running this on Linux.
might, it might be. Oh, where's your issue?
The results equals hands dot process, like after a while, we do
What's the error that you get?
that. Media type dot Python is solutions dot hands has no attribute process.
Okay, so when you initialize hands up here, did you initialize it to mp.solutions.hands? It's still, and then tracking you set to this? Did I mess that up too?
Oh, you know what it might be?
What's up?
I think in your, should this be hands here?
That's what I think so. I
Pretty
think,
sure it's hands there.
yeah,
because
this
you,
is tracking.
You defined this.
Yeah, this is tracking. Yep. All right, yes, not hands dot process is tracking dot process. This should still work though. I don't know why. Like it has this continuity camera thing and like automatically turns on here and like I don't know. I don't know.
Thank you. Have a good one.
Yo, look at it, really, it doesn't really.
So it does work.
Nope.
Nice. It is open the wrong camera, but that's. There you go.
I'm actually curious. Just wanted to open my webcam.
We'll be in. All right, when I'm recording.
Yeah.
All right.
I didn't know.